The search for life beyond Earth is just beginning, but science has already provided an encouraging answer. There are numerous planets in the galaxy, many of which are similar to Earth. Thousands of planets outside of our solar system have been confirmed by ground and space observations. Our galaxy probably contains trillions. We have no evidence of life beyond Earth. Is the origin of life in the universe simple and commonplace, or is it extremely uncommon? Welcome back to my channel. A marble in the sky. The hunt for the Earth 2.0. In the thousands of years that humans have pondered the cosmos, we are the first to know for certain that the stars beyond our sun are teeming with planets. A significant portion of them are roughly the size of the planet Earth. As with the majority of scientific inquiries, answering this one will only generate more questions. Which of these extrasolar planets harbors life? How soon does life commence? How long does it continue? The eerie stillness of the universe has a name: the Fermi Paradox. Enrico Fermi posited the infamous question back in 1950s, asking where is everybody, in relation to how big and old the universe is, and lack of any signs from an extraterrestrial civilization. Even at slow travel velocities, the billions of years that the universe has existed provide intelligent and technological life forms with ample time to traverse the galaxy. Then why is the universe so quiet? In the meantime, exoplanet discoveries over the past 2 decades have filled in a few of the parameters of the much debated Drake equation, which consists of a series of numbers that may one day tell us how many intelligent civilizations we can expect to encounter. The majority of its terms remain unanswered: the proportion of planets with life, intelligent life, and detectable technology, but the equation itself suggests that we may one day find an answer. It feels somewhat more optimistic than Fermi's paradox. We are at a crossroads in our pursuit of existence. We've discovered thousands of planets in our Milky Way galaxy, with the majority of them orbiting in their stars' habitable zones, the distance at which liquid water could exist on the surface. We believe the galaxy contains trillions of planets. Our space-based and terrestrial telescopes, as well as our remote sensing technology, continue to increase in capacity. To date, the only life we are aware of exists is in our own backyard. We are currently gazing into the void with the hope that someone is staring back. Capturing even a faint, hazy image of a distant world that resembles our own would radically alter the course of history and our position in the universe. The search for such a planet has been characterized as a hunt for Earth 2.0, a Earth-like planet, or even an Earth twin. However, each of these terms carries with it its own set of assumptions. We may or may not capture a glimpse of an exoplanet that resembles Earth. An exoplanet is a planet that orbits another star. A blue water-covered world, dotted with white clouds. And yet, even our own planet likely appeared quite different in the distant past. The term Earth-like carries with it some additional baggage. That begins with the definition of it. Which specific characteristics characterize the planet Earth-like? How could we identify these characteristics on a planet hundreds or thousands of light years away? It is possible that Earth-like planets are vastly different from modern Earth, and that life elsewhere is not life as we know it. Would we recognize existence in its absence? All of this boils down to the one question we have asked ourselves for centuries: are we alone? How life on Earth may have appeared billions of years ago, and how it may appear elsewhere. As we search the heavens for a probable twin, we must consider the stages of development, from infancy to adulthood. A rocky planet with the origins of life may have once been enveloped in an orange haze, as was the case with Earth. Our own planet was uninhabitable for millions of years, and we may discover a planet at a comparable stage, perhaps a planet with an unimaginably hot or frigid surface, that had a liquid water ocean in the past, or may develop one in the future. We typically refer to Earth-like planets as planets similar to ours today, but Earth's history has been profoundly different, despite its capacity to support abundant life. Mars, which was once warm and wet but is now frigid, dry, and forbidding, may contain evidence of past life in our own solar system. Even the present cannot be excluded. A planet with life may also be covered in a layer of ice. Europa, a moon of Jupiter, and Enceladus, a moon of Saturn, both conceal subsurface oceans within ice shells. Titan is the only other planet or moon in the solar system with rain, rivers, and lakes. In this instance, however, the liquid is composed of methane and ethane rather than water, but it could support weird life. Titan may also possess a subterranean ocean. It is not evident that other planets and moons in our solar system harbor life, but space agencies are actively investigating the possibility. The more we investigate our own cosmic backyard, the more mysteries we uncover, and as we continue to extend our senses to the outer solar system and beyond, we will continue to make new discoveries. Scientists have confirmed the existence of more than 4,000 exoplanets in our galaxy, the majority of which are presumably rocky worlds of Earth-like size. In the coming years, thousands more are expected to be confirmed. A planet in the size range of Earth that orbits a Sun-like star, at a distance that would give it a year comparable to our own, has yet to be discovered. Although it is conceivable that such planets will be uncommon, another factor explains the mystery better. Current exoplanet hunting technology, predominantly space telescopes, and the instruments they carry has difficulty resolving such systems. Future, more powerful space telescopes could help bridge this divide, or peer into the atmospheres of Earth-sized worlds found in abundance, those in close orbits around red dwarf stars, in search of signs of habitability. The day we discover life on an exoplanet will be nothing short of a Copernican revolution, permanently altering how humans view their place in the universe. We could say that the likelihood of discovering life elsewhere in the universe is increasing. Although scientists have confirmed thousands of exoplanets to date, it is likely that the Milky Way contains trillions. A significant proportion of these exoplanets are estimated to have a composition similar to Earth's. However, the universe remains resolutely silent on the matter. Even though exoplanet hunting technology is advancing rapidly, it is likely not yet advanced enough to detect signs of possible life in exoplanet atmospheres. We have seen or heard no credible indications of a technological species among the stars. The Fermi paradox is still unanswered after more than half a century. Concepts such as the habitable zone, the orbital distance from a star that allows a planet with a suitable atmosphere to retain liquid water on its surface, are assisting astronomers in sifting through the numerous possibilities to discover more likely candidates for planets capable of supporting life. However, planets with life could exist far outside this zone if, for instance, an ice-covered planet with a deep ocean and aquatic organisms existed. We employ a follow-the-water strategy to seek for life everywhere. Wherever there is water on Earth, there is life. Whether we are searching for life on Mars, ocean worlds, or exoplanets, we first seek for water. We are on the cusp of a new era in exoplanet science, sifting through the atmospheres of distant worlds to look for combinations of gases that could reveal a living planet, thanks to technology that will soon enable us to peer into the atmospheres of exoplanets, to search for signs of life. First in line is the James Webb Space Telescope, a cosmic multitasker that probes deep into the universe, in search of traces of its origin and early formation. The Webb telescope will also capture starlight passing through the atmospheres of exoplanets, providing a profile of the extant gases. This will pave the way for future, more powerful space telescopes to examine tiny, potentially rocky planets similar to our own. With more advanced technology, astronomers could detect compounds in the atmosphere that are considered biosignatures, which may indicate the presence of life. This new era of exoplanet characterization will continue with the mid-2020s launch of the Nancy Grace Roman Telescope. A sophisticated onboard instrument known as a coronagraph will obscure the glare of parent stars to disclose planets in orbit. This will result in direct images of massive gas planets. These targets are improbable to be habitable, but the demonstration of this technology will pave the way for future instruments with a higher resolution. A future telescope may discover a small, barren planet with an atmosphere composed of oxygen, methane, and carbon dioxide, in other words, an atmosphere similar to our own. We could ultimately determine whether Earth is common or uncommon. Is life prevalent or rare? We have absolutely no idea what habitable or inhabited planets generally appear like. We must continue our search. Thank you for watching.